quick review of domain and range and what makes something a function. So I don't really have the best directions here, but the question is, what is a domain and range for each of these graphs, and then are each of these graphs a function or not? So taking a look at, well, actually just take a look at the first graph. It's a set of 6 points. Okay, so when you're asked to find the domain and range, it's everything that function or relation contains in terms of x values. So I'm sure you're okay with that, but domain is x, range is y, or input, output. You probably got that down. So it's each of these specific values. So if I start with the furthest to the left point, I guess, my x values, so I'm going to list my domain down here. My x value for that point would be, if I count, -1, 2, 3, 4, 5, 6, 7, 8, 9. So -9. And then the next furthest to the left would be -1, 2, 3, 4. And notice the point above it has an x value of also -4, so I don't need to write that again. This point has an x value of 1. This point has an x value of 1, 2, 3, 4. And the last point has an x value of 5. So there's my domain. So I literally list, do not say everything from -9 through 5, because then you're saying that it would be like everything connected here. Like there's kind of making a strange curvy function, and that's not happening. It's just those specific points, so be real careful with that. And then of course your range is those y values. So I'll start from the lowest point, and actually, why don't I circle in different colors so you can follow. So this point has a y value of -2, as does this one, and I don't need to write that twice. These 2 points both have y values at +2, and I don't need to write it twice. This one has a y value of 1, 2, 3, 4, 5, and the last one, 6, 7, 8, has a y value at 8. So there's your domain and range. Then is this the function? Remember that for each input or domain value, you should have exactly one output or range value. So of course right away we can see that. Where did I see it? Right, well, I'll use it yet a different color. Right here, if I do the vertical line test, I'm going to go through the same point twice, which you know you can't do. So no, it's not a function. Or you can look at the input value of -4 has an output value, right? Input value of -4 has an output value of both 2 and 8, and that can happen if you're going to be a function. All right, then the second graph is actually a continuous function, not just a set of points. So now your domain is everything from x starting at this point and ending at this point. So that would be x equals 0 through x equals, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 over here. So that means that your domain is everything less than or equal to 10 and greater than or equal to 0. And notice those points were filled in, so it is inclusive. And then your range is everything in terms of y. So again, 0 through 1, 2, 3, 4, that's 4 up there. So y is everything from 0 through 4. Is this a function? Well, vertical line test, I'm never going to go through 2 points, so that's a good deal. You can go over to any input value, and you'll only have one output, so yes, it definitely is a function. All right, this is a review of a system of equations in 3 variables. So if you read the problem first, it says that a quilt maker plans to make 14 quilts this year from 113 yards of fabric. A small quilt requires 4 yards of fabric, a medium quilt requires 7 yards, and a large quilt requires 11 yards. She plans to make twice as many large quilts as small quilts. How many of each type of quilt should she make? So I kind of told you it's going to be a system with 3 variables, but again, you kind of go to this question, how many of each type, okay, so each type should she make? Well, that's the variable. Nothing else can vary. Everything else in the problem was fixed. So I think it's pretty clear that there are different types of quilts, and that those different types are small, medium, and large. So of course the first thing you want to do is define your variables. So I'm going to say S is the number of small quilts, and M is the number of medium quilts, and L will be the number of large quilts. So just so we kind of can keep track of that. So then I go back to the beginning. So a quilt maker plans to make 14 quilts this year. I'll stop there. Well, S, M, and L are the number of quilts, and you know that she needs 14 altogether. So that's pretty easy. Small plus the number of medium plus the number of large quilts have to total 14. And she's going to use 113 yards of fabric. Well, the variables, again, aren't in yards. So I can't just say that they total 113 yards, but I do know that a small quilt requires that many yards, medium and large, etc. So I can say 4S for 4 yards for a small quilt, plus 7M for 7 yards for a medium quilt, plus 11L will total 113 yards. So everything's in yards. And last but not least, she plans to make twice as many large quilts as small quilts. So she's going to, whatever she does to her small quilts, she's going to double that. So 2S will equal the number of large. So she's going to have twice as many large quilts as small quilts. So now you can see you have a system of equations in 3 variables. What I would encourage you to do is pause this video and see if you can solve it, and then I'll work it out quickly. So something I notice, first of all, the first 2 equations have all 3 variables and are in standard form. The third equation is not in standard form and it only has 2 variables. So you can do one, really with the third equation, you could say 2S minus L equals 0 if you wanted them all to be in standard form. So I just subtracted the L over, obviously. I'm just going to kind of draw a slash through that. It really doesn't matter. You could do substitution. Okay, another thing to think of course, I could plug in 2S for this L and for this L, and then I'd have everything in S's and M's, and I could solve that system of equation. I already have an equation here with an S and an L, so I could do elimination with these 2 to get rid of the M, so that I have another equation with an S and an L. And I think I'll just go that route since I ended with that. So what I'm going to do, since I want to take these 2 equations, I'm going to call this one A and B. I'll call this one C. So I'm going to eliminate M using A and B so that I have an equation with S and L to go down here with C. So to eliminate M, I obviously have to multiply A by -7. So I'm going to write this out, -7A, and then I'm going to just add B to it. So you kind of can follow what I'm doing. So I will have -7S minus 7M minus 7L equals -98. And equation B I'm going to keep as is. And when I add these together, I have -3S plus 4L equals 15. And, sorry, that's kind of hard to read, plus 4L. Now I have an equation with an S and an L and an S and an L, so I'm going to put C and my new equation together, and I'm going to, it doesn't really matter, but eliminate L, so I'm going to just multiply C by 4 so that I can eliminate that L. So I'm going to squeeze in 4C down here, so that's going to be 8S minus 4L equals 0, and I'm going to scooch this up a tad. When I add those together, I get 5S equals 15, and I think it's pretty clear that S is going to be 3. So I have 3 small quilts, and I can go back, and I note here that I'm going to have twice as many large quilts as I do small. So if I have 3 small quilts, 2 times 3 means I'm going to have 6 large quilts, so that is pretty easy. And last but not least, I know the total of all my quilts have to equal 14. So 3 plus 6 is 9. So that means I have to have 5 more medium quilts to make 14. What did I say? Oh, 5 medium. And there's your answer. Now again, these can be frustrating because there's not just one way to solve this. So go through it a different way and see if you can get, you know, this same answer.